Okay, so we have talked about measures of central tendency, mean, median, and mode, and measures of dispersion. That was like your range, standard deviation, and variance. Those are the things that are on the quiz that you are going to work on at home tomorrow. Today we're starting section 3.4, so we're talking about measures of position and how to find outliers in our data. So remember, you do have those formula sheets that I've given you. So the first thing that I'm talking about is on your formula sheet. It's talking about a z-score. So when I say z-score, that tells us how far our data is from the mean in terms of standard deviations. So like a z-score of 2 means it is 2 standard deviations away from the mean. A z-score of 5 is 5 standard deviations away from the mean. So the bigger your z-score, the further it is from the average. A negative z-score would mean it's below the mean. A positive is above. Yes?
Do we write this down?
It's up to you. You might write down like what a z-score is in words. The formulas, how it's calculated, this part is on your formula sheet, so if you don't want to write down your notes, it's on your sheet. It's basically your score minus the mean over the standard deviation. So the only difference between population and sample is what variable we're using for mean and standard deviation. It doesn't have any kind of units, so when you find a z-score, you don't have to put any label on it. It's just a number. You will need a calculator, so if you don't have one, pull out your Chromebook. I'd like to look at an example. Yeah.
Wait.
Yeah. Sure.
It keeps showing this one thing when I turn it on. I just didn't know if it meant something.
No. Alright, the mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7. Which of these people is relatively taller? So if you're writing this down in your notes, you don't have to write down everything. I would put for men, we are talking about a mean 69.1. Our standard deviation is 2.8. For women, the mean is 63.7. Standard deviation of 2.7. Okay, so now I want to compare two people. I can't just look at these and say, oh, well, Kevin's 83 inches tall, he's relatively taller. I want to compare them to their respective groups. So Kevin has a height of 83. What I need to do is find his z-score. The z-score is really a way of taking two different measurements and putting them in the same unit, so to speak, so we can compare them. So to find the z-score, you use your formula sheet. It's the value, so his height was 83, minus the mean. He is a man, so the mean for the men was 69.1, divided by the standard deviation. Again, he's a man, so use the standard deviation for men, 2.8. So if I do that, I get a Z of 4.96. So that means he is almost 5 standard deviations above average for his group. Now let's look at hers. So she is a female, so I'm using the mean standard deviation for females. So I take her height, which was 76, minus the mean for the women, 63.7, over standard deviation for the women, 2.7. And I get a z-score of 4.56. Typically, I round my z-scores to just 2 decimal places. Okay, so she is also taller than the average woman. But I want to know who is relatively taller. So which of these is more tall? So that would be Kevin, because he had a larger z-score. So Kevin is my answer here. If they both came out negative, that would mean they were both below average. So then who would have been respectively taller? Right. Would have been her, because she would have been closer to the average at that point. All right, so you do have to pay attention to how the question is phrased. Am I asking for the more extreme value or the one that's closer to average? Are they positives or negatives? So you do have to think about that a little bit. Any question there? Second thing I want to talk about is percentiles. So I don't remember. There's really nothing about percentiles on your formula sheet. This is really, at this point, we're not doing a whole lot calculating them. We're just talking about what they mean. So a percentile, you might see a P with a sub K. So P sub 25 would mean the 25th percentile. Is a value such that K% of the observations are less than or equal to that. If I said like P sub 10, that means the 10th percentile. Or it's like saying the value where 10% of the observations are less than or equal to it. Okay, so a percentile tells you less than or equal to. You know, when you take a standardized test and you get back that you scored in the 80th percentile, that means that 80% of the scores were less than or equal to your score. Okay, you were essentially in the top 20%, if you think about it that way. So if we look at an example, we're not going to calculate anything here, I just want you to interpret it. So the Graduate Record Examination, the GRE, is a test required for admission to many U.S. graduate schools. The University of Pittsburgh requires a GRE score no less than 70th percentile for admission into their human genetics program. Interpret this. So really all I'm asking you is, what does it mean when I say 70th percentile? So the 70th percentile is the score must be such that least 70% of the scores are less than or equal to it. So if you want to get in, when they take your score, 70% of the scores from that test have to be less than or equal to yours for you to get in. In other words, you have to be in the top 30% to get accepted. Any questions there? We talk about quartiles a lot, and we will in the coming sections. Do you know what a quartile is? It's a type of percentile that breaks our data into fours. So quartile divides it into fours. In other words, we have quartile 1, which is the same as the 25th percentile. So that 25% of the scores are less than or equal to it. Quartile 2 is the same as the 50th percentile. Quartile 3 is the 75th percentile. Quartile 4 would be the 100th percentile. 100% of the data is less than that. We don't really talk about it. It's really just quartiles 1, 2, and 3 that we would be concerned with. So quartile 1 would be where 25% is below, 75 is above. Quartile 2 is where you have half above and half below. Quartile 2 would be the same as what? What other, it's the 50th percentile. We also have another term that we've used for the number that divides the set in the middle, where they go from small to large and you take the middle number. Mode is the most often occurring. Median. The median is the middle. It's the same as quartile 2. Quartile 3 would be so that 25% were above and 75% were below. Okay. So let's take a look at an example. A group of students collected data on the speed of vehicles traveling through a construction zone, where the posted speed was 25 miles per hour. So we have 14 speeds recorded below. I want to find the quartiles for all of these. So first of all, if you're finding quartiles, they do have to be in order, small to large, which mine are. So if you just want to jot down these 14 numbers in your notes, we'll find the quartiles from that. I think it's easiest to find the second quartile first, to find the middle first. That's usually where I start. So the second quartile, that's just your median. If we have 14 values, that means it's going to be dividing them in half. So we would have 7 above and 7 below. So how would I find that? Average. We have to do 32 plus 33 divided by 2. So that's 32.5. I asked you to find and interpret. So what this means, quartile 2 is like the 50th percentile. So we could say 50% of the speeds were less than 32.5. Yes.
On that one, did you put greater than 2 since it's?
Yep. Quartile 1. So if we take the bottom half and we find the middle of it, I have 7 scores in the bottom half, so the middle one would be the 4th score, just like the median of the bottom half. So my quartile 1 is 28. How would we interpret that? 25% of the speeds were less than or equal to or 28. Or you could say 75% were above that. What is our quartile 3? 38. So that's the one, I'm not going to write this, but what percent is below? 75% would be less than the speed of 38. Okay, so the quartiles, if you just find your median, that breaks it in half, and then you find basically the median of each side of that. Okay, any questions about that? With quartiles, something that we talk about is the interquartile range. This is on your formula sheet, right under the z-score stuff. It's IQR. So you probably don't need to even write this down unless you want to tell yourself the interquartile range is basically the middle 50%. So it's quartile 3 minus quartile 1. If I find an interquartile range of 7, that means half my values were within 7 of each other. Okay, tells you where the middle 50% fall. Okay, so if I went back to the example that I was just doing, and I found the interquartile range. What was, we just need to do quartile 3 minus quartile 1. What was my quartile 3? Minus quartile 1. So my IQR, quartile 3 minus quartile 1 is 10. I asked you to interpret. What does this mean? So it's saying there is a 10 mile per hour difference in the first and third quartiles. Or you could say half of the speeds were within 10 miles per hour of one another. Okay. That's just the formula. It's the IQR is just always that. Any questions there? I want to see what happens if I take a 15th car going through at 100 miles per hour. So that speed is significantly different than all the others, right? I want to see what it does to the mean, median, standard deviation, and interquartile range. Now, did I calculate all of that stuff for the first time? No. So what's the easiest way to get like the mean, median? We had that already. Standard deviation. What do we need to do? Calculator. Okay. So go to your calculator. Let's put in the original 14 values. So you go to Stat, Edit. We are going to put these in our L1. Just do the first 14 to begin with. Josh, participate. And when we go to calculate, what are we calculating? One variable or two variables? Just one variable statistics. Okay. So for our original 14, my mean, my x bar, what does your calculator tell you?
How do you get to the point?
You go to Stat, Calculate, one variable statistics. So our mean is 32.14, is that what you guys got? If you scroll through, keep scrolling down. What do you notice? It tells you like your standard deviation and all that. It's got your N, your minimum, Q1, median, Q3. So it tells you. You can do your quartiles on your calculator as well. Yes, ma'am. Let's see if you've got your values typed in.
I think I said the first set. By a lot.
Did the quartile 1, 2, and 3 on your calculator match what we wrote down? So it's a good check. We know we did it correctly. What information did I ask for in this example? I said to give me the mean, median, which we said is the same as quartile 2. So on your calculator, it doesn't say quartile 2, it calls it median, but they are the same. So that was our 32.5. I asked for the standard deviation. Since this is just sample, we're just using that S sub x on there. So that is 6.175. And interquartile range, we calculated that, but does your calculator, can't remember. No, your calculator doesn't give it to you, but it tells you the quartiles, so you could calculate it. And we knew that was 10. Now, let's do the same thing for the 15 cars. So if you go to your stat edit, you need to add in one more value at the end. And what was the speed of this car? 100. And then we're going to go back and calculate and get our new information. So our new mean is 36.67. The new median is 33. Standard deviation, the S on there, is 18.504. The interquartile range, if you do quartile 3 minus quartile 1, so it's 39 minus 28, and we get 11. Oh, Okay, so if I'm looking, when I threw in that one extreme value, what do you notice about the mean and the standard deviation? What happened to those? They got a lot larger, right? So there was a large change in the mean and the standard deviation. The median and the interquartile range, they changed a little bit. Did they change a lot? No, that was a very slight change. So this kind of tells us what we should look at when. If we have an outlier, like the 100, it's really going to change our mean and standard deviation. So if you have really extreme values, you're better off looking at the median and the interquartile range. If all of your values are pretty consistent, like our original 14, then in that scenario, the mean and standard deviation are pretty accurate. So, I'm sorry, that is kind of tiny. Basically, which one do you look at when? And it tells you. If it's symmetric, you want to do the mean and standard deviation. If your data is skewed, you want median and interquartile range. I might jot that down if I were you. I think some of the homework questions might say, for this problem, which would be better, the mean or the median? And it has to do whether it is symmetric or skewed. The last thing I want to mention is how to find outliers. You know, I'm saying if we have an outlier, the median is better than the mean, but the 100 was an obvious, but would a speed of 40 have been an outlier? Or 50, would that have been enough to be an outlier? So we need some kind of grounds to decide that. What we are going to do is use the upper and lower fence. To set our boundaries. Anything outside this window is an outlier. If you look, your formula sheet does tell you how to find the upper and the lower fence. The lower fence is your quartile 1 minus 1.5 times the interquartile range. And that basically tells you the lowest value. So anything lower than that number would be an outlier. The upper fence is based off quartile 3. So it's quartile 3 plus 1.5 times the interquartile range. So anything bigger than the upper fence would be an outlier. Okay, you don't have to memorize these formulas. They are on your handout. You just have to be able to use them and to be able to know what does Q1 mean and IQR mean. So let's use our speed numbers. Let's use the set of 15, the one that included the 100, and find any outliers in it. So what we have to do is find the upper and lower fence. So the lower fence, we just wrote down. That's Q1 minus 1.5 times the interquartile range. Okay, for those 15 numbers, that's the last one we put in our calculator, Our quartile 1 was 28 minus 1.5 times interquartile range, Q3 minus Q1 was 10 for the original 14, but if I'm looking at the data with the 100 in it, it was 11. Okay. So if I calculate this, I get 11.5. That means any speed below 11.5 would have been an outlier. So if we're looking at this with the 100 in there, do we have anything that is an outlier on the low end? Anything below 11.5? No, so there are no outliers there. Now we find our upper fence. So that's quartile 3 plus 1.5 IQR. So quartile 3 was what? 30, I'm trying to remember. 39 plus 1.5 and the IQR was 11. And we get 55.5. So that means any speed above 55.5 was an outlier. So did we have any outliers there? Yes, just the 100. The 40s were okay. So the 100 miles per hour is an outlier. Any questions there and stuff? It's mostly relying on the calculator, putting in your data and getting all of your information from there. So make sure when you enter your data sets in the calculator, you are entering all of them correctly. So this kind of run through. Tomorrow, you are doing that take-home quiz, which you guys, I will see Friday, so you will give it to me on Friday. On Thursday, the other group is here. They are just getting a work day for section 3.4, so this homework right here. So both of these things will be due for you on Friday.